Ever trained a neural network and wondered, what is it actually doing when the loss goes down? Today, we're breaking down backpropagation, the algorithm that makes every neural network learn and the reason deep learning works at all. Every network follows the same pipeline. Feed data in, make a prediction, measure the error, adjust the weights, repeat. But there's one critical question in that third step. How do we know which weights cause the error and by exactly how much? The naive answers both fail. Randomly nudging weights is blind searching. Impossible for millions of parameters. Computing finite differences requires 2 full forward passes per weight. 2 million passes for a million weights. Neither scales. Backpropagation solves both in one backward sweep. Exact gradients for every weight simultaneously. Every connection carries a learnable weight W, every neuron holds a bias B, and training means finding better values for all of them. The forward pass flows left to right. Compute the weighted sum Z, pass it through sigmoid or ReLU, feed the result to the next layer. With x equals 2, w equals 3, b equals 1, you get z equals 7 and sigmoid of 7 is 0.999. That's the prediction. The loss then measures how wrong it is. Mean squared error for regression, cross-entropy for classification. Target 10, prediction 7, MSC loss is 9. The goal of training is to drive that number down. To drive it down, we use gradient descent. Think of the loss as a bowl and the weights as a ball on the rim. The gradient points towards steepest rise, so we move opposite. New weight equals old weight minus the learning rate times the gradient. That requires gradients, and that's where the chain rule comes in. The gradient of the loss decomposes into 3 local terms. dl over day times day over dis times z over w, each trivial to compute at its own layer. Multiplied together, they give the exact gradient. With real numbers, ours works out to negative 0.042. That negative sign means the weight needs to increase to reduce the loss. The full backprop algorithm. Forward pass, store every z in the compute loss, compute output error, then for each layer backwards propagate the error using the transposed weight matrix and activation derivative, compute weight and bias gradients, update. 1 forward pass, 1 backward pass, gradients for everything. Live example, W1 equals 3, W2 equals 2, prediction 7, target 10, loss 9. Gradients come back as negative 6 and negative 4.2. With learning rate 0.01, W1 becomes 3.06 and W2 becomes 2.042. Slightly better. Repeat thousands of times and the network converges. The learning rate eta controls how fast. Too small and training crawls. Too large and the loss diverges. The sweet spot is 0.001 to 0.01, often decayed over time. Atom adapts the rate per parameter automatically. RMSprop and SGD with momentum do the same in different ways. Initially, weights with Xavier or He loop over mini batches. One pass through the data is an epoch, run many epochs until loss plateaus. One forward pass produces the prediction. One backward pass computes exact gradients for all weights via the chain rule. Gradient descent updates every weight. Repeat that loop and you have every neural network. From a simple classifier to a billion parameter language model. Learning. That efficiency is why Backprop changed everything. Thanks for watching. If this helped you, follow, and subscribe.